Hi everyone, welcome back. So in this video, we are going to understand the LeetCode problem number 1339. It's a maximum product of splitted binary trees. Okay, it means what? We will have given a binary tree, right? We have given a binary tree where each node has a value. As you can see, each node has a value, right? And what the question is saying that you are allowed to cut exactly one edge. Let's suppose this one. This is the red one, right? Which is marked for this example. So in this example, this is a binary tree. And in this binary tree, if we want to split this binary tree into two binary tree, so we have to cut this edge, right? So we are allowed to cut exactly one edge in the tree. So this tree will be splitted into two uh, subtrees, you can say, right? So subtrees this and subtrees this, right? There will be two subtrees, and each subtrees, if we'll do the sum of these nodes values, you will get the value as the like this for each subtrees, right? So we have to compute the sum of nodes in each subtrees, right? Either we talk about this one or this one. So we have to do the sum of nodes, right? Each nodes in these trees, right? On each trees, you can say. So we have to multiply these two sum, right? And we'll return the value, right? So as you can see, we have to multiply these two sum, right? And then we have to return it. Okay. So what you have understand? What is our goal? Our goal, we have to maximize, or we have to find the maximum possible product of these sum, we can say. So the if you do this multiply, so we that is called the product, right? So we have to find the maximum possible product where we can get the maximum by cutting the one of the edge of this edge, you can say, right? Means there can be multiple possibility that we can cut this one, this one, this one, this one, or this one. What will be the maximum? That maximum we need, like for this example, we will cut this one. We can cut another also, but this only it will give the maximum possible product that is coming is 1110, right? It means what? There is maximum many possibilities, and from the many possibilities, you have to get the maximum one, right? And that is why the question is saying that you have to take the modulo of 10 to the power 9 plus 7, right, of the result. So let's try to understand in this example. So क्वेश्चन क्या कह रहा है? क्वेश्चन बहुत ही इजी है. द क्वेश्चन ये कह रहा है कि हम लोगों को मैक्सिमम प्रोडक्ट फाइंड करना है आफ्टर स्प्लिटिंग द बाइनरी ट्री. जो बाइनरी ट्री दिया हुआ है उसमें से किसी भी एक एज को स्प्लिट करना है, कट करना है एग्जैक्टली वन एज इन द गिवन बाइनरी ट्रीज, राइट? और उसको टू सब ट्रीज में डिवाइड करना है लाइक दिस. और हमें क्या करना है? इनके नोड्स की जो वैल्यूज हैं उनको सम करके और क्या करना है? एक साथ मल्टीप्लाई करके और जितने भी एजेस हैं उसके साथ हम कॉम्बिनेशन चेक करेंगे कि मैक्सिमम किस में मिल रहा है, और जिसमें मैक्सिमम मिल रहा है उसको ट्रैक करना है, उसको रिटर्न करना है. दिस इज व्हाट द क्वेश्चन सेइंग दैट, राइट? लेट्स ट्राई टू अंडरस्टैंड फर्दर. लेट्स टेक वन what you call a tree or binary tree. So binary tree contains like this. Let's suppose we have one. This is another node is 2. So this is our root node, right? This is called the root node. Root node contains children, two nodes, right? The maximum two children will be there like this. 2 or not, right? We can say less than 2. Then let's suppose this is the subtree we have. So subtree contains 4 and 5. This is what we have given. Okay. Let's suppose this is a given tree we have. Okay. Can I say if I want to do the sum of this tree, sum of what do you call tree, right? So sum of tree or total sum, we can say total sum of tree is what? 1 plus 2 plus 3 plus 4 plus 5. So this 5, not 5, this is 5, and this okay, total it will give 15, right? So total is coming 15, right? Now try to find try to cut the edge. Okay, so let's start here. Now let's try to cut the different edges. Different edges. Okay, so how we will cut this? Very first, if we'll cut, let's suppose between 2 and 4. If I will cut this one, means this edge I want to cut. So what will happen? We will remove from here like this. So after cutting this, there will be two binary tree, this binary tree and this binary tree, right? So we'll say, okay, the possibility if we will cut between 2 and 4, right? Very first. So very first subtree is A, the value is 4. Then where we have a subtree B, where the value is how many? 15 minus 4 is 11. We can say that. कह सकते हैं, right? It's easy. Then can I say if I want the product, what we will do? Subtree का value कितना है? We have 4 and this is 11. So 4 into 11 is how many? 44. So we'll say, okay, this is nothing but 44. Right, guys? Now, let's suppose what is there? Okay, between will cut from here. Okay, this 2 and 5. Let's cut this one. Now think that we'll cut this one. So previously we have cut this one, but now we will cut this one. Okay, it means what? How will it look like? It will look like this one. Okay, means this part. It means when we come here, so we will cut between how many? 2 and 5. 2 and 5. So we know that the if we will cut from between this and this 2 and 5, right? How many it will become? There will be two things. One 5. There will be 5, right? And another is 10 into 10 minus 5. 15 minus 5, we can say that, right? Means 5 into 10 is equal to 50, we can say, right? The 50 will come. Similarly, it will cut this one. This one, it will continue. Means keep looking that, okay? So if we'll cut between 1 and 3, it means if you want the product, so 3 into 15 minus 3 equal to 3 into 12 equal to 36, right? So out of this, if I want to find which one is the maximum, that's our 44, then we have 50, then we have 36. Which one is maximum? 50 is the maximum, right? So I will say here maximum product is 50, and this will be our answer for this case. I hope you are understanding till now. So can we say that if we will think like let's say, so let's think of every edge, right, as a possible cut point, right? कह सकते हैं it's a possible cut point, right? Why? So when we'll cut it, means each cut creates the two subtrees, right? How? Let's think. Very first, one subtree one subtree with sum. Let's call subtree sum, right? We can know that this is our subtree sum. If we know that we have got the value that is subtree sum for the one subtree, right? It means what? Other, how we will calculate? We have seen the example, right? Subtree with sum. I forget to write here with sum. Okay, is nothing but what? If we know the total sum minus this subtree sum. Subtree sum. If we know, then we can get the total sum, right? Like that we have seen, right? Here, where we have written the details. Yeah. If you know the subtree sum, just you need to do a total minus 4, you get 15. Like that, we'll get, right? So this is what we should try that, right? So let's think about the approach. So what approach we should use? We should use post order traversal. You know that there is many traversal, right? So we'll use the post order traversal. Okay. So what we need to do, we will use post order, that is called DFS we will use. Why? Because we will go for left subtree, right subtree, then we will go to right subtree, and then we'll go to the node. Correct, guys? We'll go post order traversal, right? Because we know that very first we'll go the left subtree, right subtree, and then the node, right? How? If this is a, let's suppose is a subtree, right? Like this. So very first you will go with this part, then you will go this part, and then you will go this part. Understand? Means for anything, very first you will complete this part, and this part, you can say that. So this is called the post order traversal. Understand? So left subtree, right subtree, and the node we will traverse, or root node we can say that. So it will ensure we compute what? Subtree sums bottom up. This is the benefit. So if we'll find the bottom of sum, so it will become easy, right? Let's understand how. Remember this example that we have seen, this example, right? We'll use the same example. Let's suppose. So very first, let's suppose we have 1 if we have, then we have 2 we have, then we have 3, then we have 4 and 5. This is what the example was saying, right? Let's go by step traversal, how we'll go. Let's suppose very first you will visit this 4, correct? If you will visit this 4, means what? What is the sum here? It is 4, right? Then let's suppose you will visit the sum here is 5. So you visited 4 and visited this, its sum is here 4, here 5. Okay. Now visit 2. So we know that this left part and right part, right? This is 4, this is 5, and this is 2. It means what? 2 plus 4 plus 5 is what? 11, right? So this total part will give 11. Now, if this total part is left, right? Left subtree, what is this part? Right part. So this is 11, this is 3. 11 plus 3 is 14, right? Then we'll go to here at 1. So this 11, this is 3, 11, 3, 14, and 1 is 15. So we'll get the 15. That is why we should use this way to find the sum, right? I hope you understand. So at every node, we will try how? We'll try, let's call it at every node. Just try. What you will try? Let's call this is a product, right? Product is equal to subtree, and this is called sum, subtree sum you say, into, right? Into, you find the total sum minus subtree sum. I hope it is an easy way to think and understand. And we have seen the example also. It is not difficult, right? So very first, we'll do the DFS and we'll calculate the total sum of the tree. And second DFS will calculate each subtree sum. And for each subtree, we'll use this formula, right, to calculate, right? What we will do in the very first, you will in the first DFS, we'll calculate the total sum, right? Let me write here. In first DFS, calculate what? Total sum of tree, right? We will do the two time of DFS. When you do the second DFS, right, you should calculate what you will calculate? Each subtree sum. And once you have each subtree sum, so for each subtree, what you need to do? You will use this formula. Calculate product. Once you calculate the product, you should do what? Track the maximum product. Understand? So this will make you easy, right? What I told? What I told? We will for each node, let's suppose if we want to find the subtree, that we will cut this one. So this part you know already the sum, right? You will calculate based on this formula, right? Similarly, I will first calculate the total sum of the tree using the DFS, then use again the DFS, calculate each subtree, and for the each subtree, calculate the product and track the maximum product. This is what we are going to do. But make sure that it's very important that you don't actually cut the tree. Okay. You only simulate every possible cut via the subtree sums. Okay. So let's go to the code and we'll try to do the live coding. So let's go to the code and do here the coding. Let me do these things, right? First, zoom a little bit. Okay. Very first, that we know that we have given this root node, right, of the tree, and from there we'll get the everything, right? So what we will need to do is, as a very first step, I told you that in step one, we should compute the total sum. So how we are going to do the total sum? Let's call it, I'll create a outside because I need to track, right, this one. So let's call we'll take a long and call total sum. Okay. And total sum initially is 0, and we'll take another is a long, and we'll say the max product we need, right? So max product is also start from 0. In the very first step, we have defined using the DFS is that you find the total sum. So to find the total sum, we know that we need the DFS. So call a DFS method. Let's call this is a DFS total call, where we'll return the root, where we'll pass the root, sorry. Okay. In the next step, we'll say step 2, where we'll use the compute max product, right? How we'll find the max product? Let's suppose this is a DFS and call this name as a product. So DFS product will take the root itself, right, and it will calculate the it will track the max product. Once this is done, means you have tracked the max product. And how will find the max product? You will say, okay, max product we have already tracked. Just take the modulo, and modulo, you know that we have to find the mod. So you need to define the mod, right? And before returning this, it should be in the int. So because return type is saying int, right? So define the mod. How will find define the mod? Let's call, there is a static, give the name final int, and this is a mod. And this mod will take 10 to power 9 plus 7, right? So define 30, then again 30, then 0 0, 10 to power 9 plus 7, right? So you define the 7. Okay, so this is what is the syntax is there. Now you have to define the DFS total. Okay, that takes the root. So let's define here. It is a helper method, so we'll say, okay, this is a private DFS method. It will take the long value, right? So return should be long. It will take the root, so you can take from here to here as a root value, right? And then implementation we need to do. So if we'll say here root, in the place of root we can define the node. So very first we'll say if the node is equal to null, we should return, right, 0. If not, what we should do, return node dot val, right? Let me check if it is val or not. Yes, this is a val, left and right. Okay, so what we need to do, we'll say val plus the method is dfs total. So itself we need to pass, and we know that we need to pass the left and right, right? So node dot left, and similarly we'll say plus right here. Okay, both child, left, right, and node. So this is node, it's left child and right child, means left subtree, right subtree, sum of total value, and the current node value is the DFS total. Okay, now we need to find the DFS product. So the method will be, definition will be almost same, so just name will be different, right? So give the name DFS product like this. Okay, let's define the method. So very first the conditions will be same, that if it is 0 will return 0, otherwise we'll go to the long left side and do the DFS product of the left side. So how? Like this, compute the product here, and in place of node we'll write the root. So we'll say, okay, what is the node? Node dot left value, we'll say. Similarly we'll go for right. So we'll say, okay, for the right node we can get through the right. So you have to pass these two argument and you will get the left and right, correct? Very first, if node is null, otherwise it is not, then left and right calculate. Once you calculate the left and right, you just need to find the total subtree sum, right? Subtree sum, and you can get from what? Node dot val plus you have the left plus you have the right. Okay, all combinations. Now you need the product. So how will you find the product? So long product is nothing but the subtree value that we have. So this subtree value we say multiply it, you know the total, you have the total sum minus this. Check the total sum. Yes, total sum. So this total sum minus this value that I told you, this is the formula that we need to use. Okay, once you find this, we should track the max product. Now it's time to track the max product. So to track the max product, you know that how to track. So max product is just, you need to math dot max, and you will pass the max product. Let's suppose the current value is 0, but it is will give something value, right? So something value will be updated. If it is more, in other cases it will keep updating the, it will track, we are tracking the max product. So this is the line of code where we will track the max product. Once this is done, you know that what you need to do. You need to return the this part return, because this is a subtree sum, right? So we have to return the subtree sum all time, and in that time only we need to track the max product. So this is what we need to do, guys. Let me check. So all cases are working fine. So thank you so much. Let me submit. So it's working fine. Thank you guys. Thank you for watching this video. In case if you have any doubt, please ping in the comment box and I'll see you in the next one. So हमने क्या किया है समझो. सबसे पहले हमें टोटल ले लेना है और मैक्स सम लेना है, राइट? और यहाँ पे क्या डिफाइन करना है, एक मोड स्टैटिक डिफाइन करना है. इसलिए स्टैटिक डिफाइन करना है क्योंकि आपको क्वेश्चन में दिया हुआ है कि 10⁹ प्लस 7 से आपको क्या करना है, मॉडलो लेना है ताकि मैक्स वैल्यू इंटीजर में रिटर्न हो पाए, राइट? और इंटीजर रिटर्न करने के लिए आपको टाइपकास्ट करना पड़ेगा. 2 स्टेप्स मैंने बताया था. वेरी फर्स्ट स्टेप इज टू डू द टोटल सम, and once you find the total sum, you need to do the again the DFS to DFS for the getting the max product. So max product we will track how. Very first you will, this is the method to find the total sum. लेफ्ट सब ट्री का राइट सब ट्री का सम निकाल लेना है और नोड वैल्यू ले लेना है. इससे आपको टोटल सम मिल जाएंगे. इन अदर केसेस आपको डिफेस प्रोडक्ट निकालने के लिए ये बेस केसेस रहेंगे. अदरवाइज लेफ्ट की प्रोडक्ट निकालो और राइट की प्रोडक्ट निकाल को और क्या करो, सम कर दो नोड वैल्यू के साथ, आपको ट्रेस सम निकल जाएगा. जैसे आपको ट्रेस सम निकल गया, आपको मैंने फार्मूला बताया था कि आप प्रोडक्ट निकाल लो. वंस यू गॉट द प्रोडक्ट, यू नीड टू जस्ट ट्रैक द मैक्स प्रोडक्ट एंड फाइनली यू विल रिटर्न द सब ट्री. इस तरह से आप ट्री को स्प्लिट कर सकते हैं और क्या कर सकते हैं. और अगर आपको स्ट्रक्चर वे में लर्निंग, थैंक यू गाइस, थैंक यू फॉर वाचिंग दिस वीडियो. इफ यू फाउंड दिस वीडियो हेल्पफुल, प्लीज लाइक, सब्सक्राइब and let us know what you want to learn next in the comment below. And thank you for watching this video.